All right. I have a question for everybody. So who of you is using SPAC for driving continuous integration for your developers? Great. Who of you is confident that those developers understand what's going on in your GitHub actions or oh man, that the reaction is priceless. Okay. How about feeling confident enough to do this with 1 or 2 commands? Nobody. Okay, hopefully this will be interesting for you. My name is Richard Berger. I work at Los Alamos National Lab, and I'm going to talk about this tool that I created in the past year or so. Last year at HPSF, I was talking about how to drive continuous integration and developer workflows using SPAC. And so you can think of this one as the sequel, what happened after. I took what I learned at that time and tried to generalize and apply it to multiple projects. And just to reset the scene, I work on multiple code teams at LANL that do HPC software that has to work on the current and the next generation of HPC systems. And so we're dealing with a mix of production codes, research codes, and it's a mix of CPU and GPU accelerated programs. Now, when we develop the software, we are not interested in a single configuration of our software. We're exploring new avenues. We're trying new programming models. We're trying different compilers, different networking stacks, different technologies, and of course, the different hardware. And so we manage this complexity by using continuous integration. We have a lot of CI jobs that build all out the different configurations of our software. And so we use GitLab CI, Jacamo runners to run on the production systems. And if we don't have those systems because of networking reasons, then there's at least a sibling system that gives us at least the same hardware and the same software configuration. Now, with these codes and these CI pipelines, we have to distinguish between 2 groups of people. On the one hand side, we have the developers who are working on new physics, new parts of the code. They have some predefined configurations they're working on and some established workflows that they're interested in. And then there's people like you, the DevOps, sysadmin types, who are actually behind the scenes creating these pipelines and the configurations on those systems. Now, for those 2 groups, we're solving 2 problems. On the one hand side, getting on a new HPC system is really tricky. You have some new hardware, some vendor-specific operating system, some drivers, libraries, and then on top of which you build your common tools, your developer stack, open source libraries, maybe some proprietary libraries, expert-controlled libraries, on top of which you build your actual application and your actual thing that you're interested in. Now, thankfully, we have all agreed upon ourselves that we use SPAC for dependency management, and that has solved or simplified this tech significantly. But using SPAC across multiple code teams at scale is quite a challenge and requires special knowledge. And so we don't want individual developers going in onto a new system and figuring out how to use SPAC and all the different tools by themselves. We want experienced people to figure out all the quirks on this new system, figure out how to do the right MPI and SPLAS libraries and so on, and then share that across the code team. Now, once you've solved this, the next thing is you have to give these configurations to your developers. If you have this all set up as a CI, the developers will come to you and ask, okay, so this thing failed, how do I recreate it? And now, if you're not careful, you will end up with this situation that developers will have some sort of alchemy. They will have a wiki that documents the 20 to 30 steps that you have to follow to recreate that one particular build. And on the other hand, you have the CI pipeline encoded in YAML files that uses the latest technology from SPAC or CMake and whatnot. But if you're not careful, you're diverging. You have 2 separate workflows. And so last year, I was presenting how you can unify this with a little bit of shell scripting. You have a driver script that drives your workflow using SPAC. And in the end, every single GitLab job has this little message which says, get the code, here's the line to get the same allocation as the CI job, and then this one line to run the script to launch it. All right, so This was very popular, worked perfectly. So why did I create a new project? With success came a different problem, scaling it across multiple code teams. So in the end, I applied this to different code teams, and I effectively had to maintain at least 3 separate copies of the SPAC deployment logic. And this particularly became very painful when I started moving everybody to SPAC version 1. Now, some projects like XCAP are even worse. They have individual CIs in their sub-projects, like 10 different CIs. And so then I had multiple copies of the same workflow management part in those projects. So I needed something to unify this and minimize my own maintenance. And so what I wanted to have was like a common base configuration that I could share across code teams, some common deployment logic, and a tool which allowed me to encodify the project-specific workflows. And it has this benefit that once you are used to that tool, you create this muscle memory that you can then use if you're moving from one code team to the other. It'll help you work on this other code team. Okay, so what is Kessel? The best way I found to talk about it is to first say what it's not. So there's a lot of tools out there that are doing all of these things, and I'm not trying to be one of them. I'm not trying to do yet another wrapper around the wrapper and so on. Instead, I'm trying to follow the Unix philosophy. I want to have a tool that does one thing and one thing only, and through the combination of that tool and other things, you get something more powerful. So Kessel is a workflow orchestration tool, and it allows you to create CI/CD workflows and developer workflows, and it establishes this uniform interface across these different things. And you have to think of it as the glue code. So what you have to do to make SPAC and CMake work together. And so the key goal of Kessel is to bridge this gap between what you do in the CI and what the developer has to type when they run interactively. And it does so by giving you a structured way to defining the workflows and gives you the necessary scaffolding for doing so. Initially, this was very SPAC specific, but over time, this became more generic. And so nowadays, I can say, bring your own package manager, bring your own CMake build system, whatever you like. The glue is just regular shell scripting and Python. And the value that Kessel brings is it allows you to define common workflows that are maybe useful for multiple people, and you can extend and customize them or write your own. Okay, I do have to mention the special relationship to SPAC because Kessel would not exist without SPAC. It was the motivating factor to write this tool. But nowadays, because it has become so general, I can say Kessel provides SPAC-based workflows for doing software deployment and developer workflows. So it utilizes SPAC, it uses its features, and because of the features of SPAC, it became so much simpler. Initially, Kessel was had lots of features that were wrapping SPAC commands, and over time, as things like the includes in SPAC or the YAML, how the YAML is parsed in environments became more powerful, I could remove some of the complexity of Kessel and really focus only on this workflow component. And the fact of the matter is Kessel itself uses itself to run its own CI, but that one is pip-based. Okay, so let's dive into Kessel. Kessel is a little bit of a wordplay. The name is German and means cauldron and kettle. So think of it as you're the evil witch that puts together different tools and makes magic potions. Well, now it's developer workflows. And the second reason is we wanted to have a Kessel run. So anybody who knows sci-fi will get that reference. So think of it as a short and simple way of making something that's usually long and complex. Kessel runs a workflow, and every workflow consists of steps. You can run individual parts of the workflow using the Kessel step command. Every step has a name, but that name is completely generic. It's dynamic based on the workflow definition. Now, every step can have command line options, and the combination of these command line options is what makes up the command line of Kessel run. It's a very simple idea, and Kessel gives you the scaffolding to write this kind of stuff. Okay, so here's a command line for doing a SPAC-based workflow. In this case, I have a command line option to select a SPAC environment, and then everything else is just a regular spec. And doing this Kessel run is exactly the same as doing Kessel step and then the different step commands. In this case, only the nth step takes command line arguments. Okay, so Kessel workflows are just Python modules and packages. So the workflow name matches the package or module name. And so you create these files using Kessel init from a template, or you can create them with Kessel create, edit them, Kessel edit. But it's just pure old Python files. Now, once you have defined workflows in your project, you can see which workflows are available for your code, and then you switch between them using Kessel activate. Workflow files are just Python files, and if you are used to SPAC packages, this will immediately feel familiar. It's the same idea of having a DSL to write something specific for your project. So you have a class that matches the workflow name, and the individual methods represent the steps. And then in order to define a sequence of those steps, you have a member function, member variable, where you just have a list of the names of those steps. And this design is really powerful because you have the capability of using inheritance and combining multiple workflows to create something more complex. And then the Kessel, the steps are then the working horse of the workflow. So here you can execute shell commands and even entire shell scripts. You can source them. An important detail here is it manipulates the parent shell. It's not running as a sub-process, but it schedules the work on your parent shell. And as I mentioned, that creates some, is a little tricky because you have to maintain state using either environment variables or file system changes. And as I showed you, you can do either the entire workflow or individual parts using the Kessel step command. And Kessel status gives you a visual representation of where are you in this workflow. All right, now last year I talked about this SPAC-based developer workflow. So this is the summary graphically. You have a SPAC environment for your code, and that encodes the logic of how to build your project using CMake. And so we use a SPAC environment to encode both our build dependencies and our build configuration, and then we create a CMake build folder that then, on top of which we run a regular CMake-based workflow. Now, with Kessel, this now looks so much simpler. You have a Python file where you inherit from different base workflows. And in this case, the build environment workflow defines the env and the configure step, and the CMake workflow gives you a build, test, and install. But don't be fooled by this very simple Python script. These default workflows have a lot of functionality built in that have grown over time. Here's a summary, not complete, of what it does right now. It activates or creates a SPAC environment. It adds or replaces the root spec, registers a local SPAC repository, sets up SPAC develop, registers Git mirrors for some of your dependencies if you have submodules, and it utilizes a build cache, which is useful for repeated CI runs. So all of this is just to make a particular SPAC environment for your code, maybe even allowing some customization, and then concretize, install the dependencies, and generate the CMake build folder on top of it. Now, this workflow, this little piece of Python code gives you already this Kessel run command line. This is all auto-generated from that Python file and the workflows. But typically what you want to do is customize at least some part of it. You might want to change how the environment is set up or some CMake specific changes. But overall, once you have it encoded as a workflow, the use of Kessel is then something like this. You have a Kessel run on top of a SPAC environment, and those will then run setting up the environment, configure, build, and test. A typical use case for a developer would be to say, I want to actually dive in, so I run this workflow until the SPAC environment and the CMake build folder is configured. and then I can dive in and look at, manipulate that CMake build folder directly with regular commands like make, ninja, and so on. Now, in some workflows, like the SPAC workflow, there are some cases where we have a special build environment. We don't want to pollute our parent shell with all those settings. And so that's where this Kessel build env comes in. Yes, it's really just a wrapper around the SPAC build env, but with some cleanups. And then another example would be, so you have some developer environment and the developer wants to go in and maybe change something about it, maybe a different version of Boost. So they do a Kessel run until the environment is set up, do regular SPAC commands, modify something, reconcretize, and then do the complete Kessel run on top of it. So this is just to show Kessel does automate a lot of things, but at the same time gives you the power to just dive in, and it doesn't try to reinvent the wheel. It's just trying to give you this extra layer of abstraction to automate things. Now, we haven't talked about the deployment side of things so far. So I use SPAC deployments to provide my developer environments and CI environments. But another use case is providing the final environment for a production system. And so, or this could also be used as a base for a container. And it turns out creating these deployments is just another workflow. So the general idea of the SPAC-based deployment workflow is you have some project-specific configuration, maybe some shared SPAC defaults across your code teams, and then there's a Kessel run which produces the final deployments on your cluster. Now, I make use of this layered configuration system that SPAC allows me to do. I have these SPAC defaults, Kessel defaults, and then the shared system defaults, on top of which I have project and system-specific project settings, and then in the final environment definitions which say, is it a Rockin' build, debug build, and so on. So a final environment might look like this. I include some common parts using templates. And the important part here is this final line, which includes the Kessel config scope, which makes this happen. OK, so and then just quickly, the deployment workflow, clone SPAC packages, sets up the folder structure of the deployment, creates an activate script so we can make those things available in your current shell. You bootstrap SPAC, you create a mirror, you download all the source code, and finally you concretize and build all the environments and clean up a little bit. OK, so the way you then utilize it, you activate this deployment using this hidden activation script, and all you then do is run a Kessel workflow, a different one, on top of it, and select one of those SPAC environments. And so in the end, I end up with the same situation as before with my previous talk last year, but now it's a Kessel run instead of sourcing a shell script. And yeah, I hope you could somehow grasp that this allows you to get something really complicated down to a single command line. It turned out to be this generic tool, and think of it as this new abstraction, which I think kind of Bill went into in CMake. Maybe there's this tool that could do this outside stuff. Maybe this could be it. And it's also kind of useful for AI agents because you don't have to waste context explaining how to use your project or build your project. You can have this as a workflow, and then the AI just has to know how to do a Kessel run. Adoption is ongoing at Alamos, at different ASC code teams, and a side benefit of this is that we're trying to have this shared DevOps effort to have a shared SPAC configuration. And yeah, it's open source. You can find it on GitHub. And yeah, let me know what you think.
All right, I think we only have time for one question while Chris gets set up for the next talk. But if someone wants to...
You need the dongle? You need the dongle?
Yeah, this is really cool. Thanks.
Okay.
Yeah, I'm curious if you could say a little bit more about kind of how adoption has been and how developers have responded to it, any particular challenges or successes in that realm.
So the free projects that I was mentioning, these are code projects, ASC code projects. They've been eager to adopt it because it saves them to deal with SPAC. So that, I mean, that's a little bit of an illusion. They don't still have to learn about SPAC if they really want to dive in, but just for recreating things, it lowers the barrier a little more. So in the end, I've seen positive feedback. There seems to be a little bit of a buzz, so I'm hoping to take advantage of it. So we'll see.
All right. Thank you again, Richard.
Yeah.